Hi, and welcome to the Consulting Specifying Engineer webcast, the evolution of stationary power generation, reciprocating engines, decarbonization, and beyond, sponsored by Cummins. I'm your moderator, Gary Cohen. Very happy to join you today on behalf of Consulting Specifying Engineer and CFE Media and Technology. Before we get started, here are some tips and tricks to help you get the most from today's webcast. If you're experiencing any issues with your slides or audio, simply refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of this webcast by adjusting the volume on your own computer or by adjusting the volume on the webcast platform. If you're having any technical problems with audio or the slide presentation, just click on the question mark in the top right corner of your screen to access a list of system checks to try. But if you do need a technician, just type a message in the Ask a Question box and the tech team will get to you as quickly as possible. Individual user experience questions will be answered in the Answered Questions box. Type any questions you have for the speaker in that Ask a Question box on the left-hand side of your screen. The live Q&A session will start in about 45 minutes. Today's webcast is being recorded, and you will receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left-hand side of your screen. Those documents will also be available with the on-demand version of the webcast. Now we're going to hear from the sponsor of today's webcast, Cummins. At the conclusion of the video, you may experience a few seconds of silence. That's just to compensate for the varied internet speeds. Please stay tuned after the video for today's presentation. All right, now for the good part. I am happy to introduce today's presenter, Michael Sanford. Michael is Cummins' energy policy leader. Flip the slide here. Sorry about that. Michael is Cummins' energy policy leader and has more than 11 years of experience in the power generation industry, having started his career with MTU On-Site Energy in 2012 and joining Cummins in 2014. He served Cummins in a variety of roles, including having led the North America Sales Application Engineering Organization, the technical marketing team, and most recently, he served as the product strategy and sales enablement leader for Cummins Sales and Service North America. Mike recently served on the Electrical Generating Systems Association Board of Directors and is actively engaged in a number of energy trade organizations. Mike, I will now happily turn things over to you.
Wonderful. Thank you so much, Gary, for the introduction. I'm excited to be here today to talk about this topic. There's a lot going on in the energy space, and especially within the stationary power generation space. And I know we're very excited to talk about reciprocating engines, but we're also looking forward into the world and the journey of decarbonization and what lies beyond that. So within today's brief presentation, we're going to talk a little bit about the contemporary, what's happening today, what does stationary power generation look like today, and just a quick glimpse of that. We're then also going to talk a little bit about the challenges that we're faced with today. What do the challenges look like related to permitting and maybe emissions requirements and technology? And then we'll look a little bit ahead. What's happening in the near future? What's happening in the immediate? And then we'll move to talk about the beyond. Beyond the immediate pressures, beyond the pressures of tomorrow, those internal and external pressures, whether they're driven by the market, driven by our own organizations, or whether they're driven by bigger factors that are driving us to make these long-range strategic plans centered around decarbonization and sustainability. And we're going to do all that in about the next 40 to 45 minutes or so. Now, before I go any further, I am going to reference code a couple times in here. I'm going to talk a little bit about NFPA and the National Electric Code. And so it is really important to appreciate the fact that today I'm representing Cummins, of course, and I don't necessarily represent NFPA in any way, shape, or form. Now, that being said, I and Cummins, of course, are always and continuously actively engaged with code driving organizations like NFPA, as well as their enforcement extensions, the AHJs in the field that you may interact with. And we're constantly engaged in those challenging and fun conversations related to interpretation of codes and standards, which is something that we're excited to support you with when you have those challenges or when you have those opportunities. And always recommend that you're bringing in a manufacturer representative to help you with those conversations where appropriate. All right, let's get to it. So I'm going to prompt you a couple of times during today's webinar, and I just want you to think through this. There's not going to be a poll that pops up. There's no chat window to plug this into. I want you to think through this. I want you to maybe say it out loud if you can. And I'll do this a couple of times. So just come with me on this journey. Why are generator sets included in modern building design? Why are they there? There's a number of reasons, and there's probably a couple that are coming to your mind. I hope there's more than one. There's a few different things that drive why a generator set is included. And again, I don't want you to overthink this. Why are generator sets included in modern building design? Why are they there? What's encouraging them to be there? And I'm going to talk just a little bit about that because I think that's important to set the baseline for today's discussion, because emergency power sources, EPSs, as defined by NFPA, are important, are critical to modern building design. And that really is the first major reason. That's the first why. It's code driven. So in this case, I've chosen a picture of a healthcare facility. Generator sets, EPSs, are part of a modern building design because they are obligated to be there. They're there to cover your life safety, your legally required loads. You have to have backup power as part of your facility design in order to help with egress or ingress of emergency services and to protect the lives of people. Super important. Now, don't get me wrong, there's other reasons why a healthcare facility may include a generator set, but code driven is one of the key reasons, especially in North America, that we see the inclusion of a generator set or an EPS in modern building design. The next one is continuity of business, keeping the building or keeping your business operations running. And what I've chosen there is a picture of a data center. Data centers, the largest certainly that I've been engaged with could be 60, 80, 100, 120 megawatts, huge facilities. And I think as many of you know, those aren't backing up life safety loads for the most part. Those generator sets are there in order to ensure that that business can continue operating and ultimately continue making money during a failure of the normal source, during an unplanned outage. So continuity of business is certainly a big one. The last one, and certainly the last one I'll talk about here today, is maybe not as common in North America due to challenges related to the way distributed energy resources are able to play and tap into the retail and wholesale markets. And this is revenue generation. There are instances in which generator sets, I'll just say generally, distributed energy resources can generate revenue by being tapped into the local utility. That picture on the far right-hand side is Cummins Fridley Interruptible Facility, which includes 5 megawatts of diesel generator sets that are there as part of a revenue generation program in coordination with our local utility. Now, these things aren't mutually exclusive, right? And I think the healthcare facility is a good example of that. A healthcare facility, first and foremost, is probably installing emergency generator sets because it's code-driven, because they're obligated to do so to cover your life safety loads, your legally required loads, and beyond. But that beyond piece is pretty important here. Most healthcare facilities want to keep operating during a failure of the normal source, because in many cases, when we're talking about a failure of the normal source, it could be from a natural disaster. It could be due to some catastrophic event where we want to keep the business running. Now, that may not be a revenue generation for that hospital, although perhaps indirectly, but the reality is, in addition to covering their code-driven requirements, that healthcare facility may want to continue operating even when it's not legally obligated to. So, a healthcare facility may fall into maybe one or more of these buckets. That last facility that I talked about, that Cummins Fridley facility with those diesel generator sets that are on site, are actually doing a little bit of all of this. right? So they're falling, that site falls into all three of those buckets I talked about. It's code-driven in the sense that those generator sets are there to cover the life safety and legally required loads of that facility. But I promise you, that's nowhere near the 5 megawatts of total capacity that's there on site. That's there because of continuity of business. Even during a failure of the normal source, that facility Cummins wants to keep operating for the duration of that outage so we can keep products moving down our production line. Additionally, as I originally highlighted, those generator sets are there as part of a demand response program or a peaking program in association with our local utility that does, of course, provide a revenue generation opportunity in the form of a kickback from the utility. So although these are not mutually exclusive, they are not mutually exclusive in a single installation may be tapping into more than one of these. All right, so if there are all these reasons why a generator set can be installed, it's also important to recognize that there are a number of existing pressures on these reciprocating engines as they're put into a facility today. So let's talk a little bit about those. And I'm going to pick on one of my absolute favorites. Some of you may have heard me talk about on the topic of emissions in the past. This probably is a topic that's not unfamiliar to you. We're going to talk a little bit about emissions because emissions, and specifically EPA and NSPS requirements, new source performance standards, which I'm not going to go into today on its own. It's a whole hour, 2 hour, 3 hour topic all by itself. But the reality is today, engine manufacturers and thus generator set manufacturers are obligated to meet certain regulatory requirements. These are these external pressures that are placed on the manufacturers of these products to ensure that the engine meets the expectation at the federal level in order to offer these products into the market. And so the one I'll pick on today is EPA and SPS. And you know, kind of again, the point to remember here is this is a requirement of the engine or of the engine manufacturer. These requirements come in a number of different shapes and sizes. I don't have the time to go into the difference between spark ignited and diesel today. I'd love to talk about it. I think some of you asked some questions about it. I hope we'll get to it at the end. But we're going to focus a lot on diesel engines today and diesel generator sets. These requirements are placed on reciprocating engines based relatively on the size of the engine, its date of manufacture, and the way it's intended to be used. And hopefully you're all familiar with the concept of tier 2, tier 3, and tier 4. Again, I'm not going to spend too much time on it today, but those are different emissions levels. You can think of them as a relative scale of emissions constituent maximums that these engines are obligated to be within in order to be offered into the market. Remember, this is a manufacturer requirement. This is something that's happening automatically and the manufacturers resolving on their own. In addition to that, those emissions levels are evaluated on a standardized test cycle, which includes pollutant weighting and all this other stuff. It's not typically stuff that you or our customers, the end user, the facility owner, has to worry about, right? This is stuff that the engine manufacturer is obligated to meet. And your expectation is that when you're putting out a specification for an emergency power system, this is kind of assumed, right? It's built into it. This isn't new by any means. You saw that chart I shared on the previous slide. It goes back more than a decade. This is kind of a known quantity. Above and beyond that, it's also important to recognize that this has to be from the manufacturer. Not only is it from the manufacturer, but it's obligated to be from the manufacturer. Manufacturers have to solve this from the factory in order to offer these products into the market. It's not possible. The EPA says you can't upfit these products in the field in order to satisfy the EPA requirements. It has to come from the engine manufacturer. But that's kind of where the line stops between the engine manufacturer's obligation and your customer's obligation. So let's talk a little bit about that. There's two types of operation I'm going to talk about here today. I'm going to talk about very briefly, and that's stationary emergency operation. And you've got to be careful with the word emergency here because it's often confused for life safety or maybe a disambiguation with legally required the NEC 700, 701 loads. There's no alignment between the EPA and NEC, so keep those separate in your mind. The EPA says if the engine or generator set comes on during a failure of the normal source, it is an emergency generator set. So that's the EPA's definition. If you turn on that generator set only when the normal source has failed, it can be considered emergency. It doesn't matter if that's serving life safety loads. It doesn't matter if that's serving legally required loads. It doesn't matter if it's serving optional loads. So it could be anything from a healthcare facility to a data center. The EPA says it doesn't matter. If you're turning it on when the normal source of power fails, it is emergency. There are still some restrictions as part of that. One, during an emergency, there's unlimited operations, maybe not a restriction, the opposite. So during an emergency situation, an emergency generator set can operate indefinitely, no limitation to its usage per the EPA. Outside of that, you get 100 hours and 100 hours only, and that's really intended for maintenance and testing. That is the purpose of those 100 hours. You see a reference there, and I saw a question come through in the pre-registration that asked about demand response for emergency engines. It's no longer allowable. It was that position by the EPA was vacated in 2015. We're 8 years past that at this point. I'm still hearing questions about it. The DER or EDR provision in the EPA within Title 40, Part 60 is vacated 8 years ago now. Not allowable. And I'll talk about how or what products you have to use in order to operate in that space. This is how the tiers, remember the tiers are these emissions requirements for stationary compression ignition or diesel engines have changed over the last few years. It's pretty simple. We went from pre-tier engines or non-tier to tier 1 in 2000 and tier 2 in 2006. That's about it. For emergency engines, not a lot has changed from a federally mandated standpoint for engine manufacturers. Let's talk about what has seen some transition, and that's non-emergency operation. Non-emergency operation is anytime that engine is operated in the presence of a normal source or where there is no normal source presence. That picture on the left-hand side is a great example of that. And again, I saw a couple of questions about this that came through that asked about the usage of a stationary engine without the presence of a normal source. Today, as far as I'm aware, the EPA would classify that as a non-emergency operation, so a remote mine site that is operating only on stationary engines would have to be considered stationary non-emergency because it's not an emergency. The normal source hasn't failed. It doesn't exist. Alternatively, an application like a combined heat and power project where the generator says operating in a base load configuration and also providing heat to be transformed into steam for hot water or whatever it may need to be. That is also considered non-emergency because it's not operating only when the normal source has failed. It is operating alongside the normal source. Because non-emergency operation could potentially be for greater duration. In fact, it's unlimited. There's no limit to the amount of operation that a non-emergency certified engine could operate. The expectations for emissions are much different. The types of applications that are most commonly associated with non-emergency are things like demand response, peak shaving, rate curtailment, interruptible. These are a lot of these words are kind of used somewhat interchangeably. My recommendation to you is if you see any of these words, you're talking with a customer, an owner, an operator, end user, an AHJ inspector, someone who's talking about these things, you need to be thinking about the non-emergency certified product, typically what we consider a tier 4 product for diesel for diesel recips today. And this is what that has looked like. That's undergone an immense amount of change, going from pre-tier to tier 1 to tier 2 into tier 4I, tier 4 interim, which is no longer a thing. We don't need to talk about tier 4 interim here anymore. Tier 4 interim is done. But that represented a significant reduction in both NOx and particulate matter onto tier 4, which is now what's in effect today for any non-emergency engines. And that represented an even more significant reduction in particulate matter. Look how small that box is compared to that original tier 1 box. This is what drove engine manufacturers like Cummins in order to invest heavily in emissions reduction technologies in the form of both in-engine, on-engine, and post-engine or after-treatment solutions in order to achieve these very stringent requirements. Okay, so I'll give you a little background on the emission standpoint. Again, I'd love to talk more about this, but we've only got so much time. Here's what you really need to know about this. Every engine manufacturer every engine or generator set manufacturer that offers generator sets into the North America market must be able to provide you with sufficient documentation that proves their engines meet this. Because again, everything I've talked about at this point is an engine manufacturer requirement, right? That's not your requirement. You don't have to produce this documentation. Now, the engine manufacturer or generator set manufacturer must be able to provide this information. So you need to ask for it. And there's 3 main documents that you should be asking for. You should be asking for an EPA compliance statement that has, most notably, the generator set model and the engine EPA family name. You want to see both of those things ideally on the same document, because that's the only thing that would prove that the generator set that's going to show up on site has an EPA certified engine. This document is absolutely critical. In the exhaust emissions data sheet, it could look something like this, right? I'm showing you examples of Cummins data sheets. You should be able to get something similar to this from any generator set manufacturer, but you got to ask. These exhaust emissions data sheets should show you the specific nominal emissions data across multiple load point for many of the major exhaust emissions constituents, and you should be able to request this and get a copy of this. You may need this for permitting purposes. If you think you need this for permitting purposes, I would highly recommend you work closely with an environmental consultant who's familiar with the permitting process to ensure you're getting the right data from the generator set manufacturer to fill out that permit. Last but not least, you should see an EPA certificate of conformity. The previous two documents come from the generator set manufacturer. I'm not going to say they don't have any standing, but they're published by the generator set manufacturer. This document, the third document I'm showing you here, is the one that comes from the EPA. And I think this document is pretty important because this is what ties the engine family name on that's on the nameplate of the engine that's in the generator set. This is what gets tied back to the actual qualification or certification of that engine. So you should be able to ask for all of these things, and you'll see these throughout the presentation, a spec note. Make sure you have this in your spec. I want you to be thinking about your master specification for emergency power sources as we're navigating through this presentation and taking notes as we go. This is a pretty important one. So far, I've covered a lot. And I've talked a lot about kind of where we are today, right? Everything up to this point is kind of what's going on today. Let's move and talk a little bit more about what's coming up, what's happening maybe a little bit today and a little bit tomorrow before we get into the beyond. So I want you to think about what are some examples of pressures or changes that you face related to emergency power system or source permitting design. These pressures could be internal, like a planned decarbonization or sustainability initiative to use alternative fuels. These could be things like a permitting agency or an environmental quality board or a Department of Environmental Quality who has certain expectations highlighted on their permit that demand compliance with a certain emissions level. Are you facing these both internally and externally? Are you hearing about these from your customers, or are they simply kind of a part of the bureaucratic process of installing a reciprocating engine on a site? Here are the ones that I see that are impacting us the most today. Okay, the big one stems from NAAQS, or National Ambient Air Quality Standards. NAAQS goes above and beyond the federal EPA NSPS requirements for those tier 2, tier 3, tier 4 constituent levels, and it highlights on a county by county basis around the U.S. where there are areas of poor air quality, and it's specifically looking for air quality based on a number of different emissions constituents. The one that we're in this group probably most concerned about from an emergency power source standpoint there's two of them, NO2, or I'll just generally say NOx, and PM, or particulate matter. CO does certainly come up and is becoming more tightly regulated. Oxides of sulfur are not as much as a concern as they once were due to ultra-low sulfur diesel, which I'll talk about here in a little bit. But NOx and particulate matter are probably the two big ones, with carbon monoxide as a close third. What's interesting about this is NAAQS at the federal level identifies the areas with a challenge. Right? It identifies the geographical regions, the counties that are outside of the expected limits based on expectations around human health, and kind of alerts those counties, alerts the state to say, you've got a problem, you've got to come up with a way to resolve this. And that's where we see the states setting up their own implementation plans to bring these counties, these regions into compliance. I love this quote because it's in, I'll read it out, Alex, I love it so much. It says, state and local agencies are not prevented from providing additional regulations beyond these regulations, and such agencies may institute additional testing requirements independent of EPA-related actions. Here's what this means. In short, owners and operators of equipment, as well as manufacturers of products like Cummins manufacturing engines and generator sets, of course, have to satisfy federal requirements. However, the states are permitted to add additional requirements outside of the EPA's scope, above and beyond. Okay, above and beyond. Have to satisfy at least the federal requirements, but can go above and beyond. This is super interesting because it makes it so that every site can have wildly different requirements from an emissions permitting standpoint. Excuse me. And those wildly different requirements can have a major impact on the project design as well as the project's success. This is increasing. The prevalence of this is increasingly and changing rapidly around the United States today. What we generally see are something maybe we're familiar with, changes on the West Coast in the California area. And just this last year, we saw some huge monumental changes to local emissions requirements based on what we're seeing in the California area. We also see challenges around major sources of emissions like the Northern Virginia area, where we know there's a massive population of data centers. And everything in between tends to be affected by the West and the East Coast. And so we're seeing these requirements not just be centered on geographical areas, but also spreading and really flowing consistently across the United States. What we're not seeing is consistency in the requirements, and that becomes very challenging to navigate for an engineer, for someone that is working on a project in one county tomorrow, or one county today and another county tomorrow. Fortunately, many manufacturers, Cummins included, of course, are able to offer solutions that can help to target or reduce the impact of these requirements. One of the most common challenges we see today, and again, I'm going to pick on the West Coast as well as that Northern Virginia area and some other areas in between, we see a huge focus on NOx emissions. There's typically a tonnage limit based on the given site, could be 100 tons a year of maximum potential to produce NOx emissions based on the number of engines on site. And with a standard tier 2 product for an emergency engine, that target can be challenging to meet. And so we'll often see an SCR installed on those products in order to reduce NOx significantly. A well-sized or appropriately sized SCR can reduce NOx easily by 90+%. But this isn't something that you want to forget about until the inspector or the permitting agency is there looking at these products going, wait a second, these things don't work. You've got to be working with the equipment manufacturer ahead of time to ensure that these products can be equipped or installed to work in the way that permit's expecting them to be. The other big one, of course, is a diesel particulate filter, and we tend to see these near areas of sensitive receptors, schools, hospitals, any high population areas. We tend to see requirements around particulate matter reduction, and so a DPF is often installed in order to help reduce PM emissions. There are other technologies. These are just two examples of technologies that are often used in order to help satisfy the requirements stemming from state and other local emissions requirements above and beyond federal expectations. But again, it is really important for either you or the environmental consultant that you're working with to have clearly communicated those state and local emission requirements in your specification so the equipment manufacturers can provide the right solution at the end of the day. The next thing I'm going to talk about here is maybe it's not exciting, but I think it is. Diesel fuel. As everything we've talked about to date, or within this conversation has been around diesel, there are some known quantities of diesel fuel, and maybe some things that I'll share here are not known to you and may surprise you. When we talk about diesel fuel, it's obviously a carbonous fuel, right? It's a relatively high carbon fuel. So when we talk about burning diesel fuel, we're talking about a very carbon intensive process, right? And as we're seeing requirements or expectations related to reducing the consumption, reducing carbon throughput, we've seen different strategies to approach this from a fuel standpoint. But let's talk a little about diesel fuel. Diesel fuel today has a typical diesel fuel, ASTM D975 ultra low sulfur diesel fuel, typically has a shelf life or a lifespan of about 12 to 16 months. That's not very long. Quite frankly, it's not a very long period of time. And generator sets, like a bulk tank like this, is certainly not an ideal application or an ideal installation for that diesel fuel. It's typically reduced further based on the fluctuations of temperature and so on. At the same time, as we transition, as the world and the US transitioned from sulfurous diesel fuel to low sulfur diesel fuel, now down to ultra low sulfur diesel fuel, that sulfur that has been removed from the fuel for good reasons, it's a pollutant, sulfur oxides are a pollutant that we're concerned about. But one of the good things that sulfur did, it did two good things for us. One, it's a natural lubricating agent that helped keep fuel systems working as they should, but it also was an natural antimicrobial and helped help stuff stop growing in the fuel tanks. And so it's lent our fuel quality to be less stable. At the same time, we are seeing a massive increase in biodiesel blending. So many of you maybe have experienced the impact of biofuels. Could be B5, could be B10, could be B15, B20. Those biodiesel fuels can significantly reduce the fuel stability, and by promoting water absorption primarily, but also biomass growth. This has been a challenge on the fuel front, but also on the reliability front, right? At the end of the day, all those applications that I talked about, why you would install a generator set is you want that product, that application to be reliable, you want it to be resilient. So this has posed a challenge while not necessarily addressing the decarbonization goal, or while not necessarily reducing the carbon throughput in the equation. So let's talk about some of the things that have cropped up in the fuel space. So I talked about how states have developed their own implementation plans and have set emissions targets that may be different than federal requirements. Likewise, we've seen states or organizations set decarbonization goals that haven't been addressed here. Let's talk a little bit about the solution in this space. And one of the things that we've talked a lot about recently is HVO. HVO is hydrotreated vegetable oil, and this is something that you should have heard Cummins talking a lot about recently. But I'll be honest, a lot of our other partners or competitors in the space have talked a lot about as well. HVO, hydrotreated vegetable oil, is a bio-based paraffinic diesel fuel produced from a renewable feedstock through a hydrotreatment process. It shares a lot with biodiesel. It's the same feedstock for the most part. And so what we'd say is, they started from the same things, but they're produced through a significantly different process, and it yields a very different result. Often when we talk about HVO, we talk about it meeting a certain fuel quality standard. EN 15940 is the standard that Cummins and most other engine and generator manufacturers tend to follow when it comes to HVO. The big bonus, why we're even talking about HVO here, it is a very low carbon fuel that greatly supports decarbonization efforts and sustainability goals with existing products. This is the key. This is the key to HVO, because a lot of what we're talking about and have talked about so far is still based around reciprocating engines, right? When I talked about lower emissions products based on state requirements, we talked about putting after treatment on top of that reciprocating engine, right? We took a diesel reciprocating engine and we took an SCR and put it on top to reduce NOx. In the same way, HVO, in the ability to use HVO, supports the decarbonization journey without a significant impact to the base technology, and thus without a significant impact to the well-known reliability and resiliency of that emergency power system. As I said, it is produced through a different process. Biodiesel is produced through esterification, whereas HVO is produced through hydrotreatment. And generally speaking, one of the other big bonuses that's kind of an unintended side effect is that HVO is a much more shelf-stable fuel. And so when you're thinking about that hospital that you worked on that has, 4 2.5 megawatt generator sets, each with 96 hours of fuel on site, and you're quickly doing the math going, how many tens of thousands of gallons of fuel may be there? That's a challenge when that biodiesel blend has a relatively low shelf life, because NFPA 110 specifically calls out fuel quality as something that has to be tested annually and remediated immediately upon a test disqualifying it within the engine manufacturer's fuel standard. So HVO offers a significant benefit in its stability over not just ultra low sulfur diesel that we use today, but also over biodiesel blends that are commonly in the market. So let's talk a little bit more about it. I think I already emphasized the first part of this maybe a little bit, and that's compatibility. This is a drop-in replacement for carbonous fuel. So it's a HVO is a drop-in place of ultra low sulfur diesel or even of biodiesel blends. No calibration change, no hardware change, no warranty change. It is a drop-in replacement. In addition to that, it can actually be blended with the existing fuel that's on site. There's no need to pump out all of that ultra low sulfur diesel or no need to pump out all the biodiesel. HVO can be added right on top, right into the fuel tank. And can be ready to run with no additional changes. This is approved from a common standpoint across all of our engines in this space. And I think you'll hear, if you do a little bit of Googling on this, you may hear similar stories from other manufacturers. Looking a little bit about testing that was done. So this is an area that Cummins, of course, has been very, very interested in, very excited about for a number of years. And so we've done a significant amount of testing in this space to actually prove out the concept on both in our engineering test cells as well in the field in order to prove out the concept of how this HVO actually works. A lot of times, and I've reviewed many different renewable specifications, renewable diesel fuel specifications over the years. And I'll be honest, one of my biggest challenges is that more often than not, those renewable diesel fuels are way out of line when it comes to meeting the engine manufacturer's quality or characteristic standards. HVO has been shown, especially when it's meeting EN 15940, to satisfy the requirements of most engine manufacturers' engines today and allow them to operate, I'd say, somewhat normally. What does normally look like? A lot of times we get asked about HVO, we get asked about how does it change the performance? What we saw was no significant difference to transient performance and start time performance. That's absolutely key for the applications that we're talking about here. No significant difference in NOx emissions. Very little power output difference. And in fact, it's so small, 1 to 2%, that we typically say that's negligible. A significant reduction in particulate matter. A slight increase in fuel consumption is a slightly lower energy content. So we'd expect to see some increase in fuel consumption. And of course, we also saw a significant reduction in smoke emissions. The other question that we're most often asked about when it comes to HVO is its availability. And today, this has been one of the challenges with HVO. I'm not here to physically sell you HVO. I don't have any. But we know what Cummins has done is shown that it can be used with our products, even some of our older products, as well as our newest product, our Centum Series Generis, that I'll talk a little bit about later, is capable of operating on HVO with no changes to calibration. What we're seeing is the market rise to this demand for this very low carbon fuel, this decarbonized fuel. And so we're seeing an increase globally in the production. However, we are still expecting to see the market demand outpace the global production capability. Although I think what we expect is from up through 2025, we expect to see the production of HVO fuels begin to reach up towards the market demand. And so you should be able to start seeing this available to you and your customers as they are talking about their decarbonization goals. And again, keeping in mind that it's something that can be dropped in. All right, let's transition a little bit and talk about what's on the horizon and why. So I want you to think about what sustainability and or decarbonization goals has your organization set? I've talked a little about this, right? I've talked about some of these drivers coming internally, some of them coming externally. And by externally, it could mean mandated at a state or federal level. It could be externally because it's your customer. You know, ultimately who's going to own the building at the end of the day may have their own decarbonization goals or their own sustainability goals, and they want to ensure that what they're procuring satisfy those. So what sustainability and decarbonization goals has your organization set, and maybe what are you seeing on the horizon? Now, I just want you to think through that briefly here. Okay. So I want to talk about some things that are happening in the market. I'm going to pick on one market in particular. I'm going to pick on a little bit on the data center space because there's so much going on there. In the data center space, internally, of course, we're seeing this increasing pressure to lower that carbon footprint. That comes from a couple different things. One, externally, those tightening emissions regulations, particularly on a state level, but also the increased publicity on some of those sustainability initiatives. We're also seeing a need to lower that ongoing operational cost, being that energy is such a huge part of that, and knowing that data center growth is significantly outpacing electrical utility infrastructure investment, knowing now that there is a lot going on with the Inflation Reduction Act as well as the IIJA that will help to build up some of the utility infrastructure investments, but still this data center growth is outpacing significantly, and data centers currently sitting at 2% of total U.S. energy consumption, expected to be 4% in just a few short years. This is significant, and this is driving pressure, public pressure around decarbonization and sustainability. In some cases, this is leading organizations to explore options outside of the norm, outside of things that we would think is typical today. So today, when we think about data centers, for example, we think about backup diesel generator sets. That's kind of the core business. But some of these organizations are partnering with organizations like Cummins to explore what technologies are out there that are above and beyond, or that are different and that offer a unique advantage. So we're seeing a lot around fuel cells today in this leading edge space, where they want to leverage this technology to help them satisfy or meet both those internal and external sustainability and decarbonization pressures. I want to talk a little about internal pressures. And so from Cummins' standpoint, we've got a lot going on ourselves that I think is important to recognize in the broader scope of the energy industry. So when we talk about Cummins, I'm not going to go into a full history of Cummins, but I think it's critical here. In addition to those market, customer, and project pressures, organizations like Cummins are establishing intense, long-range strategies driving towards a greener, cleaner, and more prosperous world. Cummins has been in the engine and power generation industry for over 102 years and counting. We've defined ourselves by our unwavering values and our promise of innovation and dependability. In the next 100 years, we'll continue to defy boundaries and unleash our ingenuity in a world hungry for new power solutions. That's to say, you may have known us as the diesel engine and generator company, and those technologies certainly aren't going anywhere or being rushed out the door, but there is something exciting happening in this space that'll help to create opportunity for our people, our industry partners, our communities, and the planet we share. For example, Planet 2050, which is something that I hope that you're familiar with from a Cummins standpoint, is our long-range business strategy with an environmental lens that uses actions, advocacy, and partnerships to drive change for a healthy planet. Our goals cover three major priorities: addressing climate change and air emissions, using natural resource sustainability, and partnering so that our communities are better because we're there. Many of you may now be reflecting on the sustainability, climate change advocacy, and or decarbonization goals that your organizations have established, or perhaps those that have been established by your customers. As I walk you through Cummins Planet 2050 and our Destination Zero strategy, I want you reflecting on your strategy and what you've heard from your customers and your industry partners. Our commitment requires changes to our products, how they're used and how they're made. We've set ambitious, specific, measurable goals through our Planet 2050 sustainability strategy, and our advocacy work aligns with these efforts. Some of our goals include things like reducing Scope 3 absolute lifetime greenhouse gas emissions from all newly sold products, partnering with our customers and industry partners to reduce Scope 3 greenhouse gas emissions from products in the field, and reducing absolute greenhouse gas emissions from facilities and operations. In addition to that, emissions compliance, as referenced earlier in today's presentation, continues to be a challenge in the stationary power generation space, with a continued focus on NOx, PM, and other constituents at state and local levels. To continue meeting and exceeding increasingly stringent global emissions regulations, we have best structured our organization to meet global compliance requirements, as well as deliver solutions that are safe and lead to a cleaner environment. The success of your projects is critical to us, and we know that we need the technical expertise in-house to support the challenging emissions and permitting obstacles that you face with almost every project. Within the power generation space, it's critical to acknowledge the importance of resiliency and reliability, two concepts that need to be maintained through any major transition within the broader energy industry. Decarbonization and renewable integration will take its time. So it's important that we have the right ramp into that space. To do this, we need to advance new energy solutions along with internal combustion engines, which have been the staple of emergency power for decades. Destination Zero is the name of Cummins Company strategy to achieve zero emissions by reducing greenhouse gas emissions and supporting the transition to decarbonized power. Our strategy is rooted in our mission of making people's lives better by powering a more prosperous world, one where we create prosperity for all stakeholders in a sustainable way. We recognize that we contribute to climate change, and we have the opportunity to make a significant impact in being part of the solution. Climate change is the existential crisis of our time and must act today to solve it. Our path to zero emissions, start lowering emissions today, incorporates well-to-wheel emissions reduction, drives wide-scale adoption, and achieves zero emissions by 2050. Cummins and its stakeholders have unique roles to play to reach zero emissions. None of us can do it alone. I think that's the key takeaway here. I'm talking about Cummins sustainability initiatives because I'm confident that you and your customer partners have similar ones as well. At Cummins, it's our role to improve the efficiency of converting energy to power. Our industry partners can use lower carbon technologies wherever they're possible. Regulators help shape policy and regulations that drive change forward. And we, of course, count on our suppliers and other partners to help us achieve those Planet 2050 goals. Some of the exciting stuff that's happening on the horizon is critical because it's not just enough to have that strategy and direction, but it has to actually yield those tangible products and solutions that help us to get there. In our case, Cummins is continuing to invest in core technologies that will pave the way for a sustainable energy future, of course, including things like batteries, fuel cells, and electrolyzers, which I've dotted throughout today's webinar. These technologies alone may not represent a sharp light switch-like transition and are already ramping into the markets they best serve, complementing existing technologies. This ensures a clear, viable path to zero-emission solutions without adversely impacting resiliency, reliability, and performance of the power solutions at your fingertips today. The world has worked diligently for more than 100 years to build the energy infrastructure and industry that exists today. It's going to take strong leadership from organizations like yours to pave the way to a sustainable energy future, and Cummins looks forward to supporting you, our communities, and the world on this journey. Before I wrap up, I have to talk about where the rubber meets the road. So many of these technologies have been talked about for years, have been tested behind closed doors, or have been featured in the preview of the world of tomorrow. Well, I'm here to tell you and show you that these solutions and applications are tangible and they're in reach. From fully battery electric buses supporting schools and transit systems to fuel cell powertrains and large-scale electrolyzers capable of producing green hydrogen, and on to the infrastructure needed to support wide-scale adoption of green hydrogen burning power generation sources, they're here today. And you see some of those examples on the screen. I've got to wrap up because I want to get some time for questions here. We talked about a lot today, and I know I was moving about 1,000,000 miles a minute, so I hope you absorbed some of it as we walk through. I talked a lot about some of the ongoing regulatory pressures, such as EPA and SPS, which are managed by engine manufacturers, but the requirements need to be called out by you and your generator set and emergency power system specifications. In a growing number of areas, we talked about external regulatory pressures on reciprocating engines that are becoming more stringent, driving the need to identify equipment solutions that satisfy an ever-changing list of requirements. Equipment manufacturers are already best equipped to provide a complete power system solution that meets typical and unique requirements today. And organizational sustainability and decarbonization goals that are being cascaded through the industry, driving collaboration and combined efforts to achieve long-term net positive impacts. Partnering with equipment manufacturers who have a clear and aligned sustainability and decarbonization goals best supports our customers, our communities, and enable us to power a more prosperous world. This is a little bit of a review on what we talked about today, going from the very beginning through all of those different technologies and regulatory pressures and beyond. I have a number of additional resources that I'm sure you're going to want to click through when you get a chance to get a hold of the slide deck, and I believe you can actually click those links right now. A number of white papers that talk about some of the basics today, as well as some of the exciting stuff that's on the horizon. And last, before I hand it over to transition into Q&A, I already shared a little bit of white papers, but this link will take you to all of Cummins power system related white papers, our brightest bulbs podcast in the top right there, a list of all of our on-demand webinars and a subscription to our Power Hour program, as well as, I want to focus you in for momentarily here, our newest Centum series generator sets, which if you click that link and follow, you'd find a little bit more about its product of the year nomination. I'd love it if you would click that to learn a little bit more. With that, I'm going to go ahead and turn it back over to Gary, who's going to start us off with the Q&A process.
All right, Mike, take a deep breath. That was a lot of information in a short period of time. We are about to put Michael to the test here. He is going to answer some questions from the audience. If you've got questions for Michael, please type them in the Ask a Question box on your screen. We'll get to as many questions as time allows. Any questions that we don't get to today will be posted online at www.csemag.com. Again, that's www.csemag.com. And remember to download a certificate of completion or a copy of the presentation. Just use that Event Resources tab on the left-hand side of your screen. All right, Mike, do you feel rested up? Are you ready to go?
I'm ready to go.
As somebody who talks fast occasionally, you have a tremendous skill for it. Well done. Let's start with, can the U.S. electrical infrastructure handle the pending loads of electrification?
What a great question. Maybe. How about that for an answer? It depends. So there is a major challenge with the electric infrastructure today in the distribution and transmission system. This is a major challenge, because when we talk about electrification, right? This is a big topic today. You're seeing on the news talking about using electricity as opposed to natural gas for certain things. I'm not going to get too far into that topic. But as we talk about electrification, of course, we're talking about a greater demand on our electric production. So, of course, the reaction is, well, if there's a greater demand, just build bigger power plants. That would be great if those power plants were able to effectively transmit that power to where it needs to go. The reality is today, in many places, the infrastructure is just not there. It's just not prepared to evenly distribute or fairly, or whatever you want to call it, to share that load across the network in a way that allows it to operate safely. And so this is where we see a demand for distributed energy resources, smaller resources anywhere between 1 kilowatt and 10 megawatts that are installed at the point of use and connected either behind of or in front of the meter in order to offer relief where it is needed, versus having to upend or rebuild the entire infrastructure. Now, don't get me wrong, there's a need to do that as well. And we are seeing federal funding, federal investment becoming available to do that, but it's going to take time. What can be deployed rapidly today and easily today, especially with FERC's Directive 2222, allows us is some of those distributed energy resources like generator sets, like fuel cells, like PV, that can tap in at point of use where it is most needed.
Perfect. And answered like an engineer. It depends. So what are the drawbacks to using biodiesels like B20?
Yeah, great question. I touched on this a little bit. Probably the biggest challenge that we see with high blends of biodiesel, of course, is that stability piece. In an application that turns over the biodiesel blends at a high rate, like a remote mining site, right? Where you've got 2 or 3, maybe more diesel generator sets that are running around the clock in order to burn that fuel, and you're topping it off with a fuel truck every couple of days. That's actually probably okay for biodiesel. That's really a good application for it. On the road, over the road trucks that are going through that tank regularly, no problem. Stationary emergency power generation, where that generator set gets run 30 minutes every month, probably not a great application for it, because that fuel is simply sitting there exposed to the air, and it's oxidizing, and it's promoting that bacterial growth that we don't like. So that's the biggest challenge that we see, especially in the emergency power space, is stability.
Got it. Interesting question here. When is Rice-Neshap's EPA ruling going to be voided in response to Tier 2 and Tier 3 gensets allowed to run for paid demand reduction response programs? They're playing Russian roulette with our winter and summer grid capacity.
Great question. So that is in reference to that demand response provision that was previously vacated. So that had been on the books for a number of years. And for those of you who aren't aware, with that original recommendation from the EPA as part of NSPS, it allowed emergency certified engines to operate in a demand response application for up to 50 hours a year. And realistically, a demand response program with up to 50 hours a year is pretty I don't know if extensive is the right word. It would cover a lot of the DER type applications for recip engines that we see in the US today. For a variety of reasons, I won't say unfortunately or fortunately, for a variety of reasons, that particular ruling was challenged by the state of Delaware, I believe, and was vacated by the EPA. I have no expectation that the EPA will make a change to reinstate that particular position to allow it back in. I don't expect that. What we see for any applications that want to participate in grid-connected usage, whether that's base loading or whether that's actually feeding power into the grid, or even in front of the meter, we're going to see those for generator sets. Those are going to have to be non-emergency certified product, like a tier 4 diesel or a low NOx sparking ignited unit.
All right. Is hydrogen fuel the future or some other fuel?
Ooh, great question. Wow. Hydrogen. Yeah. And I didn't talk too specifically about hydrogen today. And boy, I wish I just had more time to talk about hydrogen. I talked about hydrogen production when I talked about electrolyzers, and I hinted at it when I talked about fuel cells. I think the short answer is we do see hydrogen as a core technology. And let me clarify, we see the production of hydrogen as well as the generation of energy and power with hydrogen as core technologies, paving the way to that more prosperous future. Hydrogen absolutely is a keystone in that equation. There's a lot of questions asked about hydrogen today on infrastructure and storage and transportation, and heck, even just the production of hydrogen, which is why you are seeing such an emphasis on those things at the federal and state levels right now. Right now, that is happening, where we're seeing a lot of investment in that space. If you were to, say, open up your favorite internet browser, go to Google or your favorite search engine and type in Cummins hydrogen, I think that you'd find a lot of interesting information that paints a great picture of what's happening in the hydrogen space going forward. And I'll just share that I'm very excited about it.
So let's stay on that hydrogen question. How far away is Cummins from hydrogen engines, and what's Cummins doing to increase step load performance of gas and or hydrogen engines?
Yeah, one of the biggest challenges that was highlighted there that we see with hydrogen today is, of course, energy content. It's a very similar challenge that we face with diesel fuel and natural gas engines today. Today, just to give you a reference point, Cummins uses a QSK 60. So our 60-liter diesel engine produces 2.5 megawatts of power. So 60-liter, 2.5 on diesel. In order to reach 2 megawatts of power today on natural gas, we're using a 78-liter engine. And that simply comes down to energy density and the ability to combust that fuel. On the lower range, that's kind of changed. And so again, I share that as an example to say there are some similar challenges with hydrogen, and that really comes down to the investment and research and development in reciprocating engine architecture to use those fuels in a way to maintain that resiliency and reliability. I hope you heard me say resiliency and reliability enough today, because that is so important to this. Not Cummins, nor I think anyone is advocating for a light switch transition to these maybe newer technologies that don't maintain those key performance criteria that we have come to expect from our reciprocating our compression ignition reciprocating counterparts today. So how far is it away? Again, I think what I'll point you to is go ahead and take a browse around your favorite internet browser. Look and see what's happening today. There are already instances of hydrogen-based recips on the road and beyond that are effectively burning hydrogen in power generation applications, in power applications like over-the-road trucks, where those engines have been, I'd say, redesigned or are manufactured in such a way to take advantage of the properties of hydrogen.
Got it. We only have about 3 minutes left here, so we'll try to get 2 more in. We may only get 1. Let's go with what are some of the typical reasons that a generator set fails to operate?
Oh, yeah, absolutely. These are fun because they're boring. My favorite one, the top, there's typically 4 or 5 that I talked about. The top one from an installation application standpoint is generator set not in auto. Someone slammed the e-stop button probably to do service on the generator set, and that little mushroom cap button wasn't reopened or reclosed in order to allow that generator set to operate. Fuel, absolutely. Fuel quality. I talked a lot about fuel today, right? Biodiesel poses a lot of challenge when it comes to emergency power systems. So fuel is one of the number 1 reasons for a fail to start or a fail to operate. No fuel, low fuel, low coolant temperature or no coolant temperature. A failed coolant heater can be not ideal. And then, of course, batteries. I'm not talking about grid scale batteries like I was talking about here today, but those probably lead acid storage batteries on the side of the generator set. Those are often one of the number one reasons for a fail to start on a generator set. Make sure your maintenance program is up to date.
Got it. I'm going to try to sneak one more in here. We have very little time, so this will be the last one. Are all diesel generator sets capable of operating on HVO? You talked a lot about HVO today.
Yeah, boy, I want to say just yes, but there's always a little caveat, right? There's always a little star. Cummins pre-qualified many of our diesel engines to operate on HVO with no change, no calibration change, no hardware change, and so on. And so, in short, it can be dropped in with no change. We do have a couple of engines that needs to be reviewed in further detail. Work with the engine manufacturer to understand the ability of that existing or new diesel engine to operate with HVO.
Got it. Thank you, everyone, for all the great questions. And thank you so much again to our speaker, Michael Sanford, for sharing your time and expertise.
Thank you.
I'd also like to extend a special thanks to the sponsor, Cummins, for sponsoring today's event. Now that we are just about done, we do want to hear how we did. An exit survey will pop up on your screen as soon as this webcast ends. Please take a moment to complete it because we use this information to improve these webcasts. Finally, on behalf of Consulting Specifying Engineer and CFE Media and Technology, I'd like to thank you for attending. This is the end of the webcast. Thanks so much. Enjoy the rest of the day.